I am Ghanendra. I'm a PhD student at Institute of Neural Engineering. I primarily work on blood-brain barrier, but I'm here just out of curiosity to present some results on working memory. So just like few stages that working memory can be have. Let's have three stages: encoding, maintenance, and retrieval. I'll primarily talk about the maintenance phase, that how working memory is able to maintain. So some highlights: that working memory is ability to temporarily store and manipulate information, and then persistent activity exists during the maintenance phase. And then these states can be of its two types: persistent and silent, which can exist during the phase of maintenance. An existing model consider that both of these phases are operating at same time scales. So what we propose is that there might be a transition which occurs between these two phases at different time scales, which might be required for a more efficient maintenance of working memory. So some views on the memory. So classical views have been that persistent activity underlies working memory maintenance. And we know that this persistent activity is expensive and costly in nature. And so we ask that does working memory depends on neurons firing persistently, or let's say they're firing in brief bursts. So Stokes pointed out that yes, this neural state consists of activity state, which can be actually measured in experiments, but whereas these silent states or hidden state undergoes those functional structural connectivity, let's say, related to synapses, and such changes might be playing an important role in working memory. And current view says that working memory is held between the spiking induced changes, such as at the synaptic level, and those impressions which are left in the neuronal ensembles. So we are looking at that, especially what happens during this persistent activity during the maintenance phase, and what is the nature of this activity. So just a note that brain saves energy by keeping memory ensembles in an active state with the help of impressions instead of continuous spiking. So, and these observations have been there where you have self-sustained activity which occurs in working memory, and despite even the stimulus has been removed, and which points out that there might be some underlying attractors. So we ask this question: so how does these two activities encode information? And then what is the nature or the underlying mechanisms for this maintenance? And so that can be implement efficient hardware of implementation using SNNs. So we consider a very simple model, Wilson-Cohen based, where we have, let's say, three populations, pyramidal, interneurons, and another excitatory, just to differentiate between these two, and which basically form two ping networks. So first one is mostly for storing one item, and other one is for storing other item, and they operate at different frequencies. So, and they were able to give two set of behaviors. One is like normal set of oscillations, and one is mixed mode oscillations. So in first of the normal mode, where we observe that a normal persistent activity, here it shows that the first ping network is active and other ping network is low, so that it's maintaining the item one. Whereas here, with slight change in the current, you can see the two items are being maintained. That first item with PI pair is active and second EI pair is active. And then we also observe that on slight change of the parameters, we also see a change in the mode of operations, where from continuous oscillation, we have mixed mode oscillations. And they have some rates around, let's say, 10. This is around 30 in the middle one, and changes from, let's say, 30 times to 4. And in the mixed mode operations, where you can see we have regular mixed mode activity, which is like basically representing the persistent activity. And then you have active phase with large amplitude oscillations and silent phase with small amplitude oscillation between them. And then we have again persistent activity in other case where with the short case and long duration silent phase. So what we ask here is that does these tiny bursts which occur during silent phase refers to periodic refreshing of this memory? And also, does this refers to your maintenance or this silent phase? So basically, you can basically go from firing 10 times to just firing 4 times, and so that you have a bit of efficiency. And then finally, let's just summarize that a simple model was able to show this behavior using mixed mode oscillations. And then limitations are that this dynamics is very sensitive, which has normally been observed in mixed mode oscillation systems. And we are looking at how we can improve the robustness. And further, in this case, we have not considered synaptic plasticity. So key takeaways that both might be required to maintain this state, and working memory might be utilizing such mixed mode oscillation behavior in this regime for efficient maintenance at different time scales. So yeah, thank you.